Hello, everyone. Can you hear me well? Perfect. Well, welcome everyone to my talk. Thank you for coming. Thank you as well for the organizers for accepting it. It's my first talk in a KCD, and I do really love community events. And there is something which I was not really going to mention, but I will at the end. Well, let's a little bit before who I am. I'm Carlos Mestre. I'm a cloud solution architect in Microsoft. And I'm as well organizer at KCD Netherlands, as well as the Dutch Cloud Native Day, which we have coming up on the 10th of December. It's a free event. If anyone is around, we will be more than happy to welcome you. So I am from Valencia, and I think some people might have known about some of the disasters that have happened in there, the flooding. Honestly, just a catastrophe. I did want to say that for the first few days when this catastrophe happened, it was actually the people that were walking all over from Valencia city down to the towns below, bringing them food, bringing them water, medicines, and anything they needed. So I just want to highlight that, if any day everything goes down, it's going to be your neighbor. It's going to be the person next to you that's going to help you. So that's a bit the power of community. So please, if we can give a round of applause for the people that did that. I'm in, of course, GitHub, LinkedIn, Blue Sky. You can scan the QR. It will take you to these different pages. I'll show it as well at the end. But right now, let's get on with the talk. So, talking about platform real estate, about abstracting your organization tenancy model away with Crossplane. So here there's three main things that I will talk now in the bit more introduction about platforms, about tenants, and short about Crossplane before getting in with the whole shebang. So this wouldn't be a KCD talk if I didn't start with the question, what is a platform, right? It's the million-dollar question. So I am not going to try to set a definition for it, but I'm going to tell you like some of the things that I've kind of gathered with speaking with people and a couple years of experience. So if you were to ask the developers, they will tell you that the platform is the portal or API that they use to deploy their applications in containers in some kind of managed infrastructure. And also that some of these platforms might also have those tools to make development easier for them, so they can focus a bit more on the code, let's say. If you were to ask the platform team, they will tell you that it's the infrastructure as well as the tools they use to efficiently manage that infrastructure. And more often than not, this is based on Kubernetes. Of course, we're here in KCD, so we wouldn't be talking about any other kind. So if you were to ask developers, what are you building on it? What are you building on your platform? You might get very different answers based on as well the levels of proficiency of those developers. So they might tell you something like, oh, we're building applications with containers. Don't really know much more than that. Maybe a bit more intermediate level, there'll be someone saying, hey, we're building highly scalable cloud-native applications, distributed, with like resilient, high availability, etc. And a bit on the more advanced, you could have users or developers which are actually extending the Kubernetes API. And also the platform can be doing this, and that's a bit of what we're going to talk about with Crossplane. If you are to ask the platform team, what are they building in there? So they would say that they're on a never-ending journey to improve the way they manage things, infrastructure, services, etc., as well as providing more of those services to the developers, which simplifies or abstracts infrastructure away for them. There's some goals of the platform team. I put main, there might just be some of them. So of course, you do want to minimize the infrastructure spend. You want to be, you want to optimize, let's say, the infrastructure that you consume. You want to reduce toil for everyone, so that will be for both you. You want to have, not so many management efforts to manage the platform, as well as for the developers, of course. And you do want to provide self-service tools to those developer teams. But this does not come without any challenges. So, of course, we're dealing with a growing set of tools and disaggregated platform components. which are running anywhere, everywhere, any backend, multi-cloud, on-prem. It can be anywhere, and you might have to combine them. And of course, it's about gluing all those components from those different backends. You're doing that currently with infra's code, directly with code that you're automating with pipelines, etc. So let's move on and talk a bit more now about the tenancy, multi-tenancy, whatever you want to call it. If you're sharing an environment, it's more multi-tenancy, but if you're giving dedicated instances, you're dealing more with tenancy. You're dealing directly with the tenants. You don't have multiple on one, right? So what is a tenant? If we are to Google the definition of a tenant, first thing that we will get is it is a person that occupies land or property rented from a landlord. So it seems like it's about renting space, right? And of course, in the context of housing, it's a house, it's an apartment. But in the context of software, it's still rented space. But in this case, it might be an infrastructure or a platform. And a definition which I found, which I quite liked, was that a tenant is a group of users which shares a common access with specific privileges to a software instance, which in this case would be your platform. And it's also commonly used as the highest kind of level of resource hierarchy when it comes to grouping resources. So, for example, on your on your public cloud provider, you might have at the top level that tenant definition and put all your resources under that. So, what are we trying to achieve when focusing on building a tenant model? So, of course, we did say we do want to share an infra cost by sharing resources across tenants. We want to provide that, all that infrastructure and services to our tenants, and we are also trying to minimize that management effort. But there are also things that we're trying to prevent. So we're trying to prevent a tenant's workload from running in the other tenant's environment or infrastructure, so that they don't get intermixed, intermingled, you could say. We're trying to prevent the waste of resources. And we're also trying to prevent the noisy neighbors on shared resources. So, just to put an example, if you have, for example, an Argo CD instance shared across many tenants, and one of them is making very intense use of it, and if you're giving access to that interface, some others might find it laggy. They might have issues. So that's a bit the concept of noisy neighbors. And I did say I was also going to say something at least very short about Crossplane now. I'll get on with it a bit later. But Crossplane is a Kubernetes native infrastructure as code solution, which basically just runs on a Kubernetes cluster. And you could, of course, compare it to other infra as code solutions like Terraform. But in this case, instead of managing an external state, all your resources live in your etcd. They live in your Kubernetes clusters, and they're represented as Kubernetes resources. That, as for the second point, it allows you to manage non-Kubernetes resources and Kubernetes resources as CRDs. And it also allows you to create CRDs without writing operations or controllers. So you can logically group a bunch of resources and create your abstraction like that. I'll explain a bit more about that later. When it comes to building this tenant model, there's a few questions that you should be asking yourself. So first, you need to know what infra and app services do my tenants need, as well as which ones do I need as a platform team to manage everything. What scale are my tenants running, and is there a big difference between small and big tenants? What kind of isolation is needed, and at what levels? We will see that there's different levels that you can isolate things at. And how much Kubernetes do I want to expose to the users, or how much do I need to expose to the users? Are they just building on top of Kubernetes, or are they integrating with it? And last but not least, so how can I make this as efficient as possible in terms of managing it while fulfilling my tenant's requirements? So to go through all these questions, I will bring a bit of a scenario because I find that a bit easier to explain. So let's go on with the first question. So what infra and app services do my tenants need? Which ones do I need to manage everything? This is about inventorizing, right? So let's say that in this scenario, you go out to speak with your developers, with your let's say they could be developer teams internal in your company, or they could be just from outside. But you would need to go there and see what do they actually need. So in this scenario, my tenant needs 5 things. Of course, on top of that, a compute platform. But yes, they need a way to expose their applications outside of the cluster. They will need lifecycle management of DNS records. They need a way to import their secrets or to manage the secrets, have some kind of like secret management solution. They want as well to easily provide authentication services for their apps, and they want GitOps-based deployments. And of course, because we know how to navigate the CNCF landscape, we come out with a few projects which can be useful to help them. So first one, exposing applications. You could do that, of course, with Ingress and NGINX, as well as Cilium, or even Gateway API within Cilium. You can use external DNS for that lifecycle management of DNS records, external secrets for importing them into the cluster, Keycloak for providing authentication, as well as Argo CD for that those GitOps-based deployments. Now, let's move on to the platform team needs. So there might be a bit of an overlap. I might also want to have automated lifecycle of DNS records, or even manage my environments, not my workloads, with GitOps. But on top of that, I want to create resources outside of Kubernetes. I want to provide in-cluster network isolation. And I also want to manage and enforce network and RBAC policies kind of in an efficient, automated manner. So of course, I can map that again to some projects. I will be creating my external resources with Crossplane. I'll provide in-cluster network isolation with Cilium. And I will enforce network and RBAC policies with Kyverno. So when it comes to this, we know we need to have a balance, right, between the platform team's capacity, knowledge, and what the developer teams need or want, right? Like that's literally the only 2 things that we need to look at. Yeah, we know it's wrong. It's probably going to end up more like this. You're going to end up balancing or juggling those 2, so what the developer teams need and what the platform capacity and knowledge is, as well as customer policies about consuming multi-tenant environments. So they might have a policy to not run workloads in the same operating system or in the same hardware as another tenant. You also have to deal with governance and with complexity, as well as some limitations that those components will have. So that, as for the kind of inventorizing, you will also need to know at what scale your tenants will be running, and as well whether there is a big difference within those large and small tenants. So see if you want to, or if you can do anything to provide larger or smaller environments. Now there's some considerations when it comes to the sizing. So of course you have some component limitations. Again, that can be number of pods in a node, number of nodes or node pools in a cluster. I don't know, front-end IP configurations on an app gateway or a load balancer, etc. It's also important to note that large tenants can also use small environments, right? So it's not that we think, oh, it's a large tenant, they're going to need a massive environment. Well, that's probably going to be the case for production, but there's the other, the other environments, or development, test, etc. They might want to just have a small setup, but with perhaps even they accept shared resources on those environments, but they want more dedicated in their production. And as I said, this then has a direct impact on dedicated or shared, because if it's a really large, they really need a very large environment, or they might want, or they might need some dedicated instances of all that middleware. Moving on to isolation, one of the, let's say, big parts in this. So we need to know what kind of isolation is needed, as well as at what levels. These are just some. There could be more, but just to highlight, you can provide isolation at a compute level. So whether you're using shared or dedicated nodes for a given tenant, or different Kubernetes clusters even. you can provide isolation at a network level, and that can be in or outside of the cluster, right? So are you sharing those app gateways, those DNS servers, anything outside of the cluster can be shared or dedicated. And you as well will want to provide some network isolation inside of a cluster if you have a multi-tenant cluster. You can also provide isolation as a control on the control plane API level. So in this case, would be the Kubernetes, the Kubernetes API, whether real or virtual. We will see a bit more about that. And you also might want to provide isolation on the, those middleware tools and app services. So if some need dedicated instances of, things we've seen like Argo CD, Keycloak, etc. So this is a bit similar to housing, I mean, we were talking real estate, we're talking about tenancy, so let's just go with the with this comparison. So of course you can rent a room in a hotel, and then you're just agreeing, okay, I get this room and I have certain services, right? I'm gonna have electricity, water, heating, probably a TV, maybe breakfast is included, there's cleaning every day, etc. But you don't really know what the costs of all of that is, right? So that gets abstracted away for you. If you're talking about apartments, there's more shared kind of infrastructure for that electricity, for that water, provisioning within the building, but you are less abstracted, right? So you do know exactly what those things are costing you. Similarly, that would be in a single house, but of course you have a bit more dedicated infrastructure. And to be able to finish this chart, I put, let's say, a villa in which you have different houses or bungalows, right? But usually that's kind of a model similar to the hotel, so you don't know how much, the electricity, water, it's costing. That's completely abstracted from you. And similarly, we can have the same acts, dedicated share, but we've changed the services. So again, in a hotel or a villa, you might get many more services, such as that cleaning, such as that breakfast included, which you wouldn't get in more in the single house or perhaps on the apartment. So now let's talk about gates. And sorry about it's a little bit cluttered. I had it in different slides, but then I thought it was too much. So let's look a little bit first on the shared cluster. You can provide some isolation at the namespace level with network policies and other components, but we'll focus a bit more on those. And there's some disadvantages, such as cluster-scoped resources. If you have those, of course, you cannot separate them across the namespaces. And as well, you'd be sharing a Kubernetes API. In this scenario, you have some services deployed in some system namespaces that you would call, and then your tenants have, they're using namespaces from that cluster. How you can provide services to that tenant, so you can allow traffic from those systems namespaces through with network policies. And within the tenant, how they can share, well, that will be within or across namespaces if they take in more than one namespace. Let's look more at the shared multi-cluster. Again, well, in this situation, you would have kind of like a cluster mesh in here, so all the clusters are kind of connected to each other. And you can as well do separation on the network policies. Some of the disadvantages, of course, if you have tenants which have namespaces across different clusters, now we're starting to deal with quite some complexity. How you could provide services if your management cluster is meshed with the rest of clusters, you can use Cilium Cluster Mesh global services. And as well, for providing services within the tenant, that will be just within or across namespaces. Moving on to the single cluster, you have more isolation. So you would have isolation at the Kubernetes API and compute level. Some disadvantages is that there can be a bit more resource waste. And the way that you would provide services to those tenants could be either outside of the Kubernetes cluster, which has the negative point that you don't get service discovery, and as well you could do Cilium external workloads to map those external endpoints inside of your Kubernetes cluster. Again, how they provide the services, they own the cluster, so they just have open flow in between namespaces. Now with the last one, so the tenant gets multiple clusters. I've also seen this a few times, perhaps not the most efficient way, but sometimes necessary. It's similar to the previous one, so they get isolation on a Kubernetes API and compute level. Some of the disadvantages could be as well resource waste. It could be more expensive, and you're dealing as well with more complexity. And a way to provide services to your tenant, once again, as the previous one, you're either outside of the Kubernetes network without service discovery or Cilium external workloads. Last but not least, if they have a cluster mesh across the different clusters, they could use cluster mesh global services. But we are not constrained by the physical world in the same way that we are when we're renting a house, an apartment, or a room in a hotel, right? So thanks to technologies like virtualization, containerization, we can have much more flexibility when it comes to this, right? So I want to add a fifth scenario, which is a shared cluster, but with an isolated Kubernetes API. And for that, there's the project from Loft, vCluster, which enables you to deploy a virtual Kubernetes cluster in a namespace on the so-called host cluster. You can deploy your own services on that host cluster namespace, and you can also provide compute isolation, let's say, by binding kind of like nodes or node pools to given namespaces. And the way that you would be providing services, well, if you have them deployed within the same cluster, vCluster allows to expose services from the host to the guest, and you can use as well the Cilium external workloads. And within the tenant, well, they have access to that whole cluster, so they can, they can manage their own namespaces and the way that they're sharing services across. So let's go a bit on this example. Going to explain first. So you have your everything in the realm of your cloud provider, and the dotted line, it's a Kubernetes cluster. And your tenant gets access to the API of the main cluster, but they're limited to whatever is in the namespace. And on top of that, we want to deploy something. So we want that there's a keycloak realm for that tenant. We're going to do some network policies and perhaps a load balancer IP pool if we're doing the ingress or gateway API through Cilium. So let's say that we want to provide a little bit more isolation on this. So that namespace could, in fact, be a virtual cluster, as we said. So then, the tenant would talk directly to the API. Oh, sorry. We would duplicate. Sorry, I didn't explain that part. Because we're using Crossplane. Same again, if you're familiar with Terraform, you're using some providers, right? In this case, they are installed in the cluster. And if I want to create things on Keycloak backend or Kubernetes Helm or in my cloud provider, I need to install those. Providers. Now, let's say I want to put things onto that other cluster, then I have it twice. Let's say once for my cluster, once for the tenant virtual cluster. So of course, the tenant will just talk directly with the API that you have now in that new cluster, virtual cluster. And then, let's say that we want as well to have some, put some guardrails and stuff with Kyverno and provide some abstractions with Crossplane. Now let's move on more to the Crossplane part, or to how much Kubernetes do I want to expose to the users. So we're going to do it with Crossplane, of course. And why Crossplane? So first point is that you do not need to create or orchestrate pipelines, you're dealing with retry policies, resource cleanup when something fails, race conditions, etc. Crossplane is leveraging eventual consistency. So we will create things, and as they start working, they will start connecting to each other, let's say. It also enables GitOps on non-Kubernetes resources. So of course, because I can create something in my cloud provider as a Kubernetes resource, then I can include that in my GitOps setup. And it also allows me to unify the lifecycle management of resources which run in multiple backends. So you also have to ask yourself, so how much Kubernetes you want to expose, or how much Kubernetes to expose, right? So do your tenants need access to the whole Kubernetes API? Are they building on top of Kubernetes, or are they integrating with it? So that will depend, of course. Do I need to abstract things away for them? So, do I want to create some definitions that will simplify and reduce that cognitive load on the developers? And in that case, what kind of abstractions do they need, right? So just to put an example of how we're building the abstractions, I chose a web app instead of a tenant because it's easier to just put on the one screen. And say that you want to create a definition, say, of a web app. And this is a bit simplified, but you would have a deployment, service, an ingress. Those are Kubernetes resources. Then you might also want to create a SQL database and DNS entries, firewall rules, connection to that database, or even a public IP to expose that web app. And the way that one would create resources, of course, they could just create a web app directly as a Kubernetes resource definition. And in there you could abstract it away so that they only need to put what is the name of this container, what image do I need to use, and how many replicas. Of course, what maybe environment variables, other things they didn't fit in screen. And as well, something about that database. So how big do I want this database to be? You're grouping resources and create them as ones. So moving on to a bit more methodology, although not in depth because of time constraints. We want to know how I can manage this as efficiently as possible while fulfilling my tenants' requirements. So there's a few steps. The first one, it's everything we've seen up to this point on the presentation. So gather requirements for the needed services, sizing, isolation, desired extractions, and Kubernetes exposure. You would also want to categorize those platform components according to how they need to be deployed, which need to be grouped. And you will want to define a data model as well. So again, we have all these services which we already saw. And we're going to do we're going to split them a bit in some categories. So first, let's say I have my platform management global. I didn't put all of them, again, constraints of size. But say that I want to have a shared Argo CD instance across my tenants and a Keycloak instance as well for that authentication. So that would be the global resources. Then there's some resources which I want to create per tenant. So let's say I want the whole tenant to share one Keycloak realm, or a container registry, or even an app gateway, and as well an app project in Argo CD, which will limit, let's say, to where resources can be deployed into. Then you have the per cluster resources, so that will be resources which I need deployed into every cluster, regardless of whether the tenant is consuming the whole cluster or just a namespace. So in that case, I would have, again, Crossplane for providing those abstractions, as well as like Cilium and Kyberno for doing some of those guardrails and policies. And maybe you might want an app gateway as well per cluster. And then finally, per tenant environment. So again, whether this is an entire cluster or just a namespace or collection of namespaces in a cluster. We said we wanted to provide a way for developers to expose applications, lifecycle management of DNS, and as well importing secrets. So, per tenant environment, you might want to create all these instances of NGINX, external DNS, and external secrets, as well as perhaps a secrets vault or a DNS zone in that cloud provider. Moving on to the defining data model. Well, I'm not going to explain exactly, how you're going to do that, because that's even a bit outside of my field. I'm starting to learn, these things myself. But of course, now when you're using Crossplane, you're extending the Kubernetes API, right? So you're creating all these resources which are connected to each other, and how are certain configuration inherited from one to the other. You're gonna want to know all these things, right? So again, this or the next won't be a data model, but a way that you can see how I'm organizing my resources. So let's say that I have a tenant, and this tenant can have one or multiple environments. And we said that those environments can be of different types. It can be a cluster, or it can be a namespace or collection of namespaces. If it is a cluster, it will create this managed cluster abstraction. And if it's a namespace, it will deploy into the existing cluster. And then on top of that, we said that there's some resources which should be deployed per tenant environment. So of course, those will be deployed into the managed cluster. Sorry, I don't know if you can see this well, but as well, to see show some organization, some of your global resources which are a bit independent from the rest of the tenant model, like your Argo CD or Keycloak, and then you can see things that when I define a managed cluster as an abstraction, that will include a cluster itself, as well as the resources we want per cluster. And then looking a bit more at the tenant, there will be some RBAC deployed with all of them, and they create an environment. That's the abstraction I'm providing for them. And on that environment, they'll be able to choose whether it's a namespace or a managed cluster. And if it's a managed cluster, you can see what will get deployed together. And on top of that, you will have those environment resources that we said. So that NGINX instance or external secrets, the secret store, etc. So in here, we're looking at how do components relate to each other, where does a certain configuration is coming from, what inherits from where, and as well, what forces resource recreation, right? So if you change something at a higher abstraction, you need to know what's that going to be the effect down the line. So looking a bit as well at this image, it's not the one with the V cluster, but in the case that they get an entire cluster. So we're talking about grouping resources. It's not harder than that. So you will have in here the environment resources that I want for every tenant environment. You will group as well the ones that need to be deployed into the whole cluster. Also, what is the definition of your tenant? So again, now we're talking things inside a cluster, inside the tenant's namespace or outside the tenant's namespace, in the cloud provider, as well as, of course, all the Crossplane providers that you need to create all these resources. And last but not least, as well, like some of those global resources. So it is all about grouping. It's actually not harder than that. Then after, from the word to the facts, it's a bit different once you do it. Of course, it has its added complexity, but it's all about grouping resources and exposing them as units, let's say. So let's wrap this up a bit. Of course, we had some questions at the beginning, which we've gone through. And like everything else in this field, the answers will, they do depend, right? So when it comes to your inventory, they depend on the kind of workloads that your customers will run and the way that you want to manage those tenants. It will depend on the size or type of both your organization or your customers or tenants. Once again, on your organizations or your customers' strategy, policies, and governance requirement for consuming multi-tenant environments or shared resources, as well as the customer's need and proficiency with Kubernetes. So do they need to access those lower-level resources, or can I do with abstractions? And also, of course, the proficiency, size, and range of knowledge of your platform team. And some key takeaways as well about each of these points. So you do need to understand what are the tools that are needed to do the job, both for you, both for your developers, your tenants, as for you as a platform team. As well, focus on optimizing infrastructure always. You need to understand the limiting factors of each of the stack's components as well. So like we said, like number of nodes, like those upper limits, let's say, also on the shared resources, so for Keycloak, how many realms, or depending on the size of your instance, I don't know, you need to understand that. You also need to understand the factors that force isolation at the different levels, of course, to provide a good abstraction of the good abstractions. And you also need to standardize, or it would be good to standardize delivery of services and solutions. So even if you don't create that much of an abstraction, maybe the developer can go and still create an SQL database, but you've put some guardrails. Instead of being able to define 100 variables, they can define 4. Or building abstractions with Crossplane when needed or when they are convenient. And finally, leveraging the orchestrator you already have, which is Kubernetes, and it's fantastic. Plan and build your platform's API. And I'm just at the 0 mark, so that was good, just on time. Thank you very much, everyone.
Well, you are spot on timing.